Are you a data scientist? Do your tools make it easy to track your experiments, deploy to a machine learning model to production, and manage a GPU cluster? This free book from O'Reilly can teach you how to do all that. It's about tuning neural nets, making them scale, and then deploying them to the real world.
Hi everybody, welcome to Practical Deep Learning for Coders. This is part one of our two-part course. I'm presenting this from the Data Institute in San Francisco. We'll be doing 7 lessons in this part of the course. Most of them will be about a couple of hours long. This first one may be a little bit shorter. Practical Deep Learning for Coders is all about getting you up and running with deep learning in practice, getting world-class results, and it's a really coding-focused approach, as the name suggests. But we're not going to dumb it down. By the end of the course, you'll have learned all of the theory and details that are necessary to rebuild all of the world-class results we're learning about from scratch. Now, I should mention that our videos are hosted on YouTube, but we strongly recommend watching them via our website at course.fast.ai. Although they're exactly the same videos, the important thing about watching them through our website is that you'll get all of the information you need about kind of updates to libraries, file locations, further information, frequently asked questions, and so forth. So if you're currently on YouTube watching this, why don't you switch over to course.fast.ai now and start watching through there, and make sure you read all of the material on the page before you start, just to make sure that you've got everything you need. The other thing to mention is that there is a really great strong community at forums.fast.ai. From time to time, you'll find that you get stuck. You may get stuck very early on, you may not get stuck for quite a while, but at some point you might get stuck with understanding why something works the way it does, or there may be some computer problem that you have, or so forth. On forums.fast.ai there are thousands of other learners talking about every lesson and lots of other topics besides. It's the most active deep learning community on the internet by far, so definitely register there and start getting involved. You'll get a lot more out of this course if you do that. So we're going to start by doing some coding. This is an approach we're going to be talking about in a moment called the top-down approach to study, but let's learn it by doing it. So let's go ahead and try and actually train a neural network. Now, in order to train a neural network, you almost certainly want a GPU. GPU is a graphics processing unit. It's the things that companies use to help you play games better. They let your computer render the game much more quickly than your CPU can. We'll be talking about them more shortly, but for now I'm going to show you how you can get access to a GPU. Specifically, you're going to need an NVIDIA GPU, because only NVIDIA GPUs support something called CUDA. CUDA is the language and framework that nearly all deep learning libraries and practitioners use to do their work. Obviously, it's not ideal that we're stuck with one particular vendor's cards, and over time we hope to see more competition in this space, but for now we do need an NVIDIA GPU. Your laptop almost certainly doesn't have one, unless you specifically went out of your way to buy like a gaming laptop. So almost certainly you will need to rent one. The good news is that renting access, paying by the second for a GPU-based computer is pretty easy and pretty cheap. I'm going to show you a couple of options. The first option I'll show you, which is probably the easiest, is called Crestle. If you go to Crestle.com and click on sign up, or if you've been there before, sign in, you will find yourself at this screen, which has a big button that says Start Jupyter and another switch called Enable GPU. So if we make sure that is set to true, Enable GPU is on, and we click Start Jupyter, and we click Start Jupyter, it's going to launch us into something called Jupyter Notebook. Jupyter Notebook, in a recent survey of tens of thousands of data scientists, was rated as the third most important tool in the data scientist toolbox. It's really important that you get to learn it well, and all of our courses will be run through Jupyter. Yes, Rachel, you have a question or a comment?
Oh, I just wanted to point out that you get, I believe, 10 free hours. So if you wanted to try Cressel out, you're not having to pay right away.
Yeah. He may have changed that recently to less hours, but you can check the FAQ or the pricing, but you certainly get some free hours. The pricing varies because this actually runs on top of Amazon Web Services, so at the moment it's 60 cents an hour. The nice thing is, though, that you can always turn it on, start your Jupyter without the GPU running and pay a tenth of that price, which is pretty cool. So Jupyter Notebook is something we'll be doing all of this course in, and so to get started here we're going to find our particular course. So we'd go to Courses, and we'd go to FastAI 2, and there they are. Things have been moving around a little bit, so it may be in a different spot for you when you look at this, and we'll make sure all the information, current information, is on the website. Now, having said that, that's, the Cressel approach is, as you can see, it's basically instant and easy. But if you've got, an extra hour or so to get going, an even better option is something called Paperspace. Paperspace, unlike Cressel, doesn't run on top of Amazon. They have their own machines. And if I click on, so here's Paperspace, and so if I click on New Machine, I can pick which one of their 3 data centers to use. So pick the one closest to you, so I'll say West Coast. And then I'll say Linux, and I'll say Ubuntu 16. And then it says Choose Machine, and you can see there's various different machines I can choose from and pay by the hour. So this is pretty cool. For 40 cents an hour, so it's cheaper than Cressel, I get a machine that's actually going to be much faster than Cressel's 60 cent an hour machine. Or for 65 cents an hour, way, way, way faster. Right? So I'm going to actually show you how to get started with the Paperspace approach, because that actually is going to do everything from scratch. You may find if you try to do the 65 cents an hour one that it may require you to contact Paperspace to say, like, why do you want it? That's just an anti-fraud thing. So if you say fast.ai there, then they'll quickly get you up and running. So I'm going to use the cheapest one here, 40 cents an hour. You can pick how much storage you want. And note that you pay for a month of storage as soon as you start the machine up, right? So don't start and stop lots of machines, because each time you pay for that month of storage. I think the 250 gig, $7 a month option is pretty good. But you only need 50 gig. So if you're trying to minimize the price, you can go there. The only other thing you need to do is turn on public IP so that we can actually log into this. And we can turn off auto snapshot to save the money of not having backups. All right, so if you then click on Create Your Paperspace, about a minute later, you will find that your machine will pop up. Here is my Ubuntu 16.04 machine. If you check your email, you will find that they have emailed you a password. So you can copy that, and you can go to your machine and enter your password. Now, to paste the password, you would press Control-Shift-V, or on Mac, I guess, Apple Shift-V. So it's slightly different to normal pasting, or of course you can just type it in. And here we are. Now we can make a little bit more room here by clicking on these little arrows. I can zoom in a little bit. And so as you can see, we've got like a terminal that's sitting inside our browser, which is kind of quite a handy way to do it. So now we need to configure this for the course. And so the way you configure it for the course is you type curl http://files code.fast.ai/setup/paperspace pipe bash. Okay, and so that's then going to run a script which is going to set up all of the CUDA drivers, the special Python Python distribution we use called Anaconda, all of the libraries, all of the courses, and the data we use for the first part of the course. Okay, so that takes an hour or so, and when it's finished running, you'll need to reboot your computer. So to reboot, not your own computer, but your Paperspace computer. And so to do that, you can just click on this little circular restart machine button. Okay, and when it comes back up, you'll be ready to go. So what you'll find is that you've now got an Anaconda 3 directory, that's where your Python is. You've got a data directory, which contains the data for the first part of this course, the first lesson, which is our dogs and cats. And you've got a FastAI directory, and that contains everything for this course. So what you should do is cd FastAI, and from time to time you should go git pull, and that will just make sure that all of your FastAI stuff is up to date. And also from time to time you might want to just check that your Python libraries are up to date, and so you can type conda env update to do that. All right, so make sure that you've cd'd into FastAI, and then you can type Jupyter Notebook. All right, there it is. So we now have a Jupyter Notebook server running, and we want to connect to that. Right? And so you can see here it says copy paste this URL into your browser when you connect. So if you double click on it, then that will actually copy it for you. Then you can go and paste it, but you need to change this localhost to be the Paperspace IP address. So if you click on the little arrows to go smaller, you can see the IP address is here. So I'll just copy that and paste it where it used to say localhost. Okay, so it's now HTTP and then my IP and then everything else I copied before. And so there it is. So this is the FastAI Git repo, and our courses are all in courses, and in there the deep learning part 1 is DL1, and in there you will find lesson1.ipynb, IPython notebook. So here we are, ready to go, depending whether you're using Crestle or Paperspace or something else. If you check courses.fast.ai, we'll keep putting additional videos and links to information about how to set up other good Jupyter Notebook providers as well. So to run a cell in Jupyter Notebook, you select the cell and you hold down Shift and press Enter, or if you've got the toolbar showing, you can just click on the little Run button. So you'll notice that some cells contain code, and some contain text, and some contain pictures, and some contain videos. So this environment basically has, it's a way that we can give you access to a way to run experiments and to kind of tell you what's going on, show pictures. This is why it's like a super popular tool in data science. Data science is kind of all about running experiments, really. So let's go ahead and click Run, and you'll see that cell turn into a star, the one turned into a star for a moment, and then it finished running. Okay, so let's try the next one. This time, instead of using the toolbar, I'm going to hold down Shift and press Enter, and you can see again it turned into a star and then it said 2. So if I hold down Shift and keep pressing Enter, it just keeps running each cell. Right? So I can put anything I like, for example, 1 + 1 is 2. Okay. So what we're going to do is we're going to, yes, Rachel.
This is just a side note, but I wanted to point out that we're using Python 3 here.
Yes, thank you. Python 3.6.
And so you may get some errors if you're still using Python 2.
Mm-hmm. Yeah. And it is important to switch to Python 3. Now, well, for FastAI you require it. But increasingly a lot of libraries are removing support for Python too. Thanks, Rachel. Now, it mentions here that you can download the dataset for this lesson from this location. If you're using Cressel or the Paperspace script that we just used to set up, this will already be made available for you. Okay? If you're not, you'll need to wget it as shown. Now, Cressel is quite a bit slower than Paperspace, and also there are some particular things it doesn't support that we really need, and so there are a couple of extra steps. If you're using Cressel, you have to run 2 more cells, right? So you can see these are commented out. They've got hashes at the start. So if you remove the hashes from these and run these 2 additional cells, that just runs the stuff that you only need for Cressel. I'm using Paperspace, so I'm not going to run it. Okay, so inside our data, so we set up this path to data/dogscats that's pre-set up for you. And so inside there, you can see here I can use an exclamation mark to basically say I don't want to run Python, but I want to run bash, right? I want to run shell. So this runs a bash command, and the bit inside the curly brackets actually refers, however, to a Python variable. So it inserts that Python variable into the bash command. So here is the contents of our folder. There's a training set and a validation set. If you're not familiar with the idea of training sets and validation sets, it would be a very good idea to check out our practical machine learning course, which tells you a lot about this kind of stuff, of like the basics of how to set up and run machine learning projects more generally.
Would you recommend that people take that course before this one, or?
Actually, a lot of students who would, as they went through these, have said they've liked doing them together. So you can kind of check it out and see. The machine learning course, they cover some similar stuff, but all in different directions. So people who've done both, say they find it, they each support each other. I wouldn't say it's a prerequisite. But if I say something like, hey, this is the training set and this is the validation set, and you're going, I don't know what that means, at least Google it, do a quick read, because we're assuming that you know the very basics of kind of what machine learning is and does to some extent.
And I have a whole blog post on this topic as well.
Okay, and we'll make sure that we link to that from course.fast.ai.
And I also just wanted to say, in general with FastAI, our philosophy is to kind of learn things on an as-needed basis.
Yeah, exactly. Don't try and learn everything that you think you might need first, otherwise you'll never get around to learning the stuff you actually want to learn.
Exactly. And that shows up in deep learning, I think, particularly a lot.
Yes. Okay, so in our validation folder, there's a cats folder and a dogs folder. And then inside the validation cats folder is a whole bunch of JPEGs. The reason that it's set up like this is that this is kind of the most common standard approach for how image classification data sets are shared and provided. And the idea is that each folder tells you the label. So there's each of these images is labeled cats, and each of the images in the dogs folder is labeled dogs. Okay, this is how Keras works as well, for example. So this is a pretty standard way to share image classification files. So we can have a look. So if you go plot.am show, we can see an example of the first of the cats. If you haven't seen this before, this is a Python 3.6 format string. So you can Google for that if you haven't seen it. It's a very convenient way to do string formatting, and we use it a lot. So there's our cat, but we're going to mainly be interested in the underlying data that makes up that cat. So specifically, it's an image whose shape, that is the dimensions of the array, is 198 by 179 by 3, so it's a three-dimensional array, also called a rank 3 tensor. And here are the first 4 rows and 4 columns of that image. So as you can see, each of those cells has 3 items in it, and this is the red, green, and blue pixel values between 0 and 255. So here's a little subset of what a picture actually looks like inside your computer. So that's will be our idea, is to take these kinds of numbers and use them to predict whether those kinds of numbers represent a cat or a dog based on looking at lots of pictures of cats and dogs. So that's a pretty hard thing to do. And at the point in time when this data set actually comes from a Kaggle competition, the Dogs versus Cats Kaggle competition, and when it was released in, I think it was 2012, the state of the art was 80% accuracy. So computers weren't really able to at all accurately recognize dogs versus cats. So let's go ahead and train a model. So here are the 3 lines of code necessary to train a model. And so let's go ahead and run it. So I'll click on the cell, I'll press Shift Enter, and then we'll wait a couple of seconds for it to pop up, and there it goes. Okay, and it's training. And so I've asked it to do 3 epochs, so that means it's going to look at every image 3 times in total, or look at the entire set of images 3 times. That's what we mean by an epoch. And as we do, it's going to print out the accuracy, is the last of the 3 numbers it prints out, on the validation set. Okay. The first 2 numbers we'll talk about later. In short, they're the value of the loss function, which is in this case the cross-entropy loss for the training set and the validation set, and then right at the start here is the epoch number. So you can see it's getting about 90% accuracy. And it took 17 seconds. So you can see we've come a long way since 2012. And in fact, even in the competition, this actually would have won the Kaggle competition of that time. The best in the Kaggle competition was 98.9, and we're getting about 99%. So this may surprise you that we're getting a Kaggle winning as of end of 2012, early 2013, Kaggle winning image classifier in 17 seconds, and 3 lines of code. And I think that's because, like, a lot of people assume that deep learning takes a huge amount of time and lots of resources and lots of data. And as you'll learn in this course, that in general isn't true. One of the ways we've made it much simpler is that this code is written on top of a library we built, imaginatively called FastAI. The FastAI library is basically a library which takes all of the best practices approaches that we can find, and so each time a paper comes out, that looks interesting, we test it out. If it works well for a variety of data sets and we can figure out how to tune it, we implement it in FastAI, and so FastAI kind of curates all this stuff and packages up for you, and much of the time, or most of the time, kind of automatically figures out the best way to handle things. So the FastAI library is why we were able to do this in just 3 lines of code.